Hey everyone, and welcome to today's webinar. I'm Chris O'Connor, Executive Director at ZeroLight, and I'm delighted to be joined by David Randle, Worldwide Head of Spatial Computing at AWS. David, thanks for joining.
You're very welcome. Thanks for having me, Chris. Really looking forward to discussing this exciting topic with you today.
Just to start with a little housekeeping. If you have any questions, please click on the questions button and enter them there. We will then follow up directly after this session. We'll also send you a recording of the webinar. Please feel free to share this to your colleagues. So, why is it time to consider streaming XR experiences for automotive retail? Well, it's because all the key pieces of the puzzle have now come together. Customers want immersive digital experiences. Spatial computing is key to the digitalization of the automotive industry. VR hardware is developed and mature enough to be used by consumers, and ZeroLight and AWS have proven this solution works. So throughout this webinar, we'll continue to highlight these key factors. So 66% of consumers want to experience a car at a dealership, which shows there is still a desire for customers to visit retail locations. 30% of consumers would be attracted by in-store immersive digital experiences. And we see 40% higher conversion rates for products that have been 3D visualized. This tells us that there's interest from the automotive customer for immersive experiences. Let's look at the technology to deliver this, starting with the power of spatial computing, then the drawbacks of traditional VR, and then finally, what makes a CloudXR experience. So let's start with a quick intro to ZeroLight, AWS, and spatial computing. At ZeroLight, we provide cloud-based visualization solutions for the automotive industry and beyond. We have three main products: Palette SDK, which is used to build configurators for web and retail across a whole range of devices, from media on demand to 3D streaming and XR. Spotlight Suite is a cloud-based toolset for creating advertising and marketing media via a user-friendly UI or a powerful on-demand API. And OmniStream is the accumulation of 8 years of experience streaming from the cloud. This product enables any third party to use our technology to stream any application from the cloud. We'll have a look at these two products today: CloudXR via Palette SDK, where ZeroLight will develop the full solution for you, and CloudXR via OmniStream, where we'll help scale your VR experience. We have a long and successful partnership with AWS. Our solutions are developed to run in the Amazon cloud, and our latest partnership status being the Automotive Software Competency. I'll now hand over to David to explain why spatial computing is fully supported by AWS and should be on everyone's radar.
Thanks so much, Chris. Again, pleasure to be here, and it's a joy to see great partners like ZeroLight developing on AWS and leveraging our most modern infrastructure and services to achieve new capabilities for customers. This idea of getting pixels delivered to eyeballs right at full fidelity has been, I think, a quest for a long time, starting with requiring pretty heavy machinery below your desk, heating you up as well. And so seeing that evolution move to the cloud and delivering those pixels to anyone, anywhere has been a pretty radical transformation. So it's awesome to see you guys at the forefront of that innovation. I'll speak a little bit about what we're doing at AWS that enables partnerships like this and ultimately helps our customers deploy immersive experiences at scale. It starts by looking at how we define spatial computing at AWS. We look at spatial computing as the merge of three critical bits of data. Part of that data is called 3D space, or what we refer to as 3D space. This includes how you represent something that exists in the real world or even artificially created as a 3D asset, whether that's a CAD source data set or point clouds or LiDAR scans or artistic meshes. Anything that can represent something or a space in 3D is a pretty critical form of data that is required to create immersive experiences. So that's section number one. The next section is location and time data. When is something happening? Where should it be happening? How should I present it to a user? What's the relevance of that particular time and space? So that's another very important data component to create spatial experiences. Lastly, something we describe as behavior, which is why something is happening. This is typically driven by IoT data, metadata associated with assets, data coming from simulation and modeling outputs, and all of this is important data because it creates, relevance and context ultimately. When all of these come together, we believe that we're helping people create experiences that merge real-world inputs, including behavior, location, and time, with the simulation of that 3D space, ultimately blending the physical world with the fully virtual. This is our core purpose within spatial computing at AWS. And this is the foundation of where we invest, from partners to infrastructure to services. What this is doing for customers is enable them to create a pretty interesting set of use cases to address their business challenges. And so if you take everything I just described and package it into different solutions across the product development value chain, that's where we see the most the most applicable use of these technologies. It starts to affect almost every line of business in an organization, from design engineering all the way to post-sales and service. Today, we're going to be speaking quite specifically about the sales, marketing, and advertising use cases, which typically relies on what we call immersive commerce. How do you take content that lives virtually and give it a third dimension to create better confidence in that product or better confidence in that particular decision that a consumer is making? And we do that through all sorts of different tools, including using 3D real-time high-end visualization to give somebody a much more convincing emotion with that particular product. So we're going to dive into that today, but we're supporting many use cases across the product development lifecycle. What underpins this is something that's a bit broader, and this is worth contextualizing for the audience here today. So when we look at what's next with spatial computing, we see challenges mostly surrounding access to what we call spatial data. Spatial data is a combination of what I said earlier: 3D space, location, time information, and behavior data. And most organizations have a bit of a hard time managing this and filling gaps within these data sources. And that's typically because most of these applications historically have been very siloed and very, use case centric. They've been very point-based solutions. And what we see happen is that when customers can start to connect the dots between spatial data and the business that they're serving and the use case they're serving, and do that in a scalable fashion, they can start to create much more value out of this type of data and out of spatial computing in general. And so the way this works is by investing in the creation and management of spatial data, first and foremost. This initiates a flywheel that allows organizations to build and operate immersive experiences at greater scale, which then allows them to better serve and interact and help users interact with immersive experiences, which then drives more demand for spatial data, which requires, creation and management, serves more opportunity to build and operate more solutions. So that part of the flywheel in the center you see is something that we see happening within enterprises that help them create immersive experiences at larger scale. What this ultimately does is it allows these organizations to serve multiple lines of business with a single data strategy centered on a spatial data lake, right? This is a managed format of this modern set of data. And that in turn becomes a very valuable repository of assets and data, which allows then for better simulation, creating intelligence around this information, AI/ML operations, generative AI features, which we'll talk about in a second, automation, prediction. And so this becomes a very elegant way to turn what has historically been regarded as a cost center of assets, right? People have historically said it costs us an investment to create immersive content, spatial data, 3D models, digital garages, whatever you may want to call it. Now we're seeing customers say, once I've made that investment, I can deliver a lot of value based on that now. So it becomes a revenue generator versus just a pure cost center. So that's the big shift that's happening within organizations powered by spatial computing. So So we're going to zoom in a little bit on the relevance of this in conjunction with generative AI as well. It's beyond a trending word these days. I think we're starting to see the massive implications of creative content being developed with some pretty amazing foundation models. And so it's worth taking a step back quickly and looking at AWS's position on the generative AI stack. So for today, we'll keep things a little superficial, but you can go into this information at your own will. The best way to describe this is that we are investing in 3 critical layers of the generative AI stack. And these are the macro layers, but they're all equally important, and we're investing in all of them at AWS. So I'll start bottoms up. On the bottom layer is what we refer to as the infrastructure, which is typically used to train foundation models, or FMs, and then run these models in production, right? These are the core foundation models that are trained on massive data sets to then become intelligent on that particular topic or that particular domain. And to give some examples, some of that acceleration investment we've made is in our own silicon around Trainium and Inferentia. These are specialized instance types specifically for doing kind of what they're named, right? Training and inference. And then we make pretty heavy investments in the most capable NVIDIA accelerators as well, as you've seen some recent announcements. This gives us the right foundation to then train these foundation models and then run the models in production. The middle layer provides access to all of these large language models and other foundation models that are becoming popular today, including things like AI21 Labs, Anthropic's foundation models, Cohere, Stability AI, which offers some creative generative AI features, as well as our own Amazon Titan models, right? So these are all an array of foundation models we're also adding to this list on a routine basis. And these give customers the ability and tools to build and scale generative AI applications as easily as possible with as much flexibility as possible, right, through a single pane of glass. At the top layer, we have applications that are built leveraging those foundation models so that for certain use cases, you can get access directly to that end user application that builds on the foundation models without having to do that yourself. And some examples of that are leveraging Amazon Code Whisperer, which reviews code that you've developed and optimizes that code for production, as well as things like Amazon Q, which is our virtual expert platform that ties into your business data in a secure, scalable way, and then translates that into a humanized interface where you can have natural language interactions with the data set that lives in your organization, as an example. I'll end by saying that this is a huge topic for us and it's a massive investment. This also requires closing a pretty big educational gap. And so we're training more than 29 million people by 2025. That's our goal, to get these topics and get this knowledge out into the market so that generative AI components can start to be integrated into all sorts of experiences. We believe that spatial computing and generative AI have a natural marriage, and by connecting these dots, we believe we're going to be better able to serve customers and better serve that human-machine interaction and evolve that human-machine interaction to be even more accessible than it's ever been before. So I'll end there. Back to you, Chris. Hopefully that's a little bit about our overall strategy, our approach, and what we're doing to invest in spatial computing and generative AI.
Brilliant. Thanks, David. That's super interesting. Now we're going to take a look at spatial computing as an automotive sales tool using virtual reality. So here at ZeroLight, we've had a lot of experience in developing VR experiences, especially for automotive retail. Starting with Audi in 2016, deployed to over 600 locations worldwide, up to Lucid, where VR was available in locations across the US and Europe. And mostly recently, we have Aston Martin, who helped take retail VR technology to the next level, which we'll take a deeper look into later. So for automotive retail VR solutions, we always see the same requirements. The highest possible visual quality. The car needs to look real. We need to produce a solution that is simple to scale. We always need a fully configurable digital twin. The tool is for users to see their exact configuration. and the solution must be usable by everyone. That means no VR knowledge is required. The VR experience is primarily a sales tool, and that's what it should be focused on. And finally, the solution needs to be secure and resilient, especially when the OEM's digital twin data is involved. So rather than highlighting the success and challenges of VR from my point of view, I've asked some old friends that led these VR solutions to provide a short quote. So starting with Marcus, who led the Audi retail VR experience, he highlights the amazing achievement at Audi with the scale and quality of this solution, but also the challenge of maintaining and supporting this cutting-edge hardware across the globe. We use 2x K6000 NVIDIA GPUs in SLI. This enabled the quality level you see in this video, but this required a huge IT support investment. Florian at BMW highlights how amazing the immersive experience was when combined with a physical chair, but users didn't want to be holding onto controllers. They wanted to be naturally interacting with the digital twin. Hand tracking would have been great at the time, but we had to settle with simple controller intersections. And at Cadillac, Skip drove the development of the Cadillac VR solution, which showed the complete range of Cadillac SUVs in VR. He explained that while this was cutting-edge sales tool with beautiful visuals, there were many challenges in deploying to dealerships, including the space required for the hardware at the time and the learning curve required to take advantage of this sales experience. And finally, Thomas, who pioneered much of the Lucid Motors sales journey, explains how amazing and immersive the VR experience was, with multi-headset shared sessions and fully configurable digital twins. But while physical hardware shortages proved challenging, the biggest issues facing VR at the time was the dreaded cable and the risk of a customer becoming entangled in this cable. So many of the technical blockers described by those VR retail pioneers have gradually been removed over the last 8 years. We no longer need the dedicated speed, and best of all, the cables have disappeared. No more tripping or getting a customer tangled. All the tracking is now built into the headset. Headsets have become much lighter and easier to wear. Hand tracking removes the need for controllers. The high-end workstation has moved into the cloud. The same visual fidelity we could achieve with all the hardware in the first image can now be created with this simple setup. And the pieces of the puzzle are now coming together. Let's take a look deeper into what actually makes a CloudXR experience. So at the core, we have NVIDIA CloudXR. It is the protocol that streams extended reality content from a cloud provider like AWS to off-the-shelf consumer-grade headsets like MetaQuest and the Vive XR. David, and you have lots of experience with getting NVIDIA CloudXR working in the cloud, and there's been many refinements over the past. Maybe you can share a bit of that experience in getting applications running.
Yeah, for sure. So although it may seem new, running CloudXR as a utility to get pixels transported is not a new concept, right? We've been working with the teams at NVIDIA and continuously investing in making CloudXR adoption easier on AWS, and that's been a multi-year journey, right? In fact, I remember speaking at Autodesk University about 2.5 years ago about this topic and how we just started to introduce an Amazon Machine Image, an AMI, and a developer package to make integrating CloudXR easy for developers back then. And so that journey has continued and it's evolved, but it's our quest to make sure that getting access to cutting edge utilities like this, especially ones that fill solution gaps in AWS services, is easy for folks to access. And so one thing I love about this story is that working with ZeroLight as an integrator of CloudXR behind the scenes to deliver an overall package for customers to create a simpler approach for their solution, in this case, vehicle configurators, is kind of a joy for us, right? Seeing that pipeline work and investing on the back end to make sure that this just works. And there's an elegant connection between the software layer and the infrastructure is exactly, the dreams we have by investing in these solutions. But yeah, NVIDIA CloudXR is certainly a mature and continuously maturing solution in terms of the endpoints that it can serve. And we continue to look at how we can up-level the performance, the fidelity, and making sure that it's available globally on the best infrastructure to meet the needs of automotive customers.
Yeah, and that's exactly true. And so why is this technology important? Exactly because it enables us to take complexity of VR setups away from the users and into the cloud. We've built a solution on AWS to provide an intuitive experience for customers, an easy to use and maintain solution, and the dealers, both for the dealers and the OEMs. And this is a product that is efficient for the OEMs to scale. So this is what a CloudXR experience in retail can look like. In this VW showcase, the customer interacts with the 4K touchscreen, which is pixel streamed from a cloud configurator to a simple web browser running on this device. Once they have configured their vehicle, they can pick up a headset and see exactly the same vehicle being cloud streamed to the headset, allowing the customer to explore their configuration spatially, get closer, and look at the details and the features that they have chosen. So at the front end, like I keep saying, simplicity of the hardware is key. We have a standalone VR headset, such as the Meta Quest, an iPad. This could be any device with a web browser to control the experience. At least 50 megabits per second Wi-Fi internet connection. And finally, an optional display to cast the experience to. And then there's the back end that powers the solution. This is where the complexity lives. It is fully managed by ZeroLight, removing the requirement for localized IT and hardware support. There are three main parts: the headset app, the experience controller, and the VR experience running in the cloud. So we have the Unity app, which provides a user-friendly start to the experience. The MQTT service manages communication and state between the three applications. The web apps manage the connection to the cloud in the same way as if we were streaming directly to a browser. And finally, the real-time experience runs on a dynamically scaled AWS G5 instance. So I'll quickly pass over to David to delve a little deeper into those key AWS components that provide resilience and scale to this solution.
Yeah, it's always good to see a AWS architecture, right, to validate that this is an actual solution versus just a dream. So it's a pleasure to speak through what it's taken to create infrastructure and a service layer to support the experiences that Chris is mentioning. I'll divide this into three key areas, and these are the components that typically would allow an organization to create experiences like you're seeing. The first is at this deployment, storage, and database layer, right? So this is where data and information is stored and then transmitted ultimately into the applications to generate the pixels. And the main things to highlight here are AWS S3, Simple Storage Service, which is object storage with industry-leading scalability, availability, and security. This is where the assets get housed. That's the green bucket you see on the left. Ultimately, this works closely with DynamoDB, which is a database that's a fully managed serverless database with single-digit millisecond performance at any scale, which means no cold starts, no version upgrades, no maintenance windows, no patching, no downtime. So a lot of advantage to maintaining a persistent database store of that information as well, in conjunction with the physical object storage in S3. Then lastly, I'll touch on CloudFront, which is a low latency content delivery service, which uses 600 plus globally dispersed points of presence to make sure data getting from the cloud backbone to an end user, wherever they are, is happening with as little latency as possible. So these services work together in orchestration through this architecture to make sure that information is flowing elegantly from the cloud to the end user application. The next section I'll talk about is the Kubernetes control plane. We leverage Amazon EKS or Elastic Kubernetes Service to automatically manage the availability and scalability of the Kubernetes control plane nodes, which ultimately are responsible for scheduling the containers, managing the application availability, storing the cluster data, and other key tasks that pass information around the cloud. Lastly, I'll talk about the core infrastructure, the instances that ultimately drive the visual compute to generate these pixels in real time. Historically, we've offered G4DN and more recently the G5 instance family types. These are specifically NVIDIA-based instances that are focused on graphics, supporting graphics intensive applications. So they have best-in-class chipsets to provide that graphics compute capability. For example, the G5 includes an NVIDIA A10G with 24 gigabits of memory, and the G4 includes NVIDIA T4 instances with starting with 16 gigabits of memory. So these are highly capable graphics compute processors that allow ultimately the pixels to be generated in an architecture like this. So a little bit about how this works on the back end to support ZeroLight's products that have been highlighted before. I'll go a little bit into availability of these of the infrastructure in the next couple of slides. So back to you, Chris.
Thanks, David. Yeah, and complex technology never comes without its share of challenges. So just to set everyone at ease, we've broken down those challenges, and we're going to delve deeper into some of these topics to explain how we tackle them and how we create an available and resilient service. So, David, I'll pass straight over to you to explain the data center locations.
Absolutely. So this doesn't happen, right, without having compute as close to users as possible, or with technologies that allow you to serve real-time experiences while still being remote from the backbone. And this is where CloudXR specifically has offered a pretty tremendous advantage. We offer 33 launched regions globally with 105 availability zones, and there's announced plans for 6 more additional regions and 18 more availability zones. And so when you look at the coverage map, we're continuously investing and expanding that to make sure that we have highly available compute and infrastructure as close to the areas of the world that make use of this infrastructure. So that's without question. But historically, what's needed to have happened is that you would need to push implementations like this much closer to the user in order to reduce that latency, which ultimately results, especially in VR, in potential dizziness or effects that come with not delivering pixels in that real-time manner. But with the advent of CloudXR, we've been able to not sacrifice the latency and the ability to deliver those pixels to an end user, but we've been able to push that workload back into our core regions and availability zones as well. So this offers a pretty tremendous advantage where you can rely on our main regional backbone and local zone backbone to serve and run these applications without sacrificing that end user experience with typically which has had slower latency. So this is a pretty amazing shift that's happened, that we can push these workloads back into the core infrastructure. These areas are available in the most kind of populated, most in-demand areas for compute. So here's a map of some of our data center locations that support ZeroLight's ambitions to reach customers on a global footprint. I'll talk a little bit more about the additional infrastructure, including the performance and control that customers have, in just a few minutes. So back to you, Chris.
Yeah, I was just going to say the ones we're highlighting here are the ones that we deployed to for a recent deployment. And then We also wanted to highlight here that cost is always a big consideration when we talk about streaming content. This needs to be all weighed against the cost of hardware, IT support, infrastructure, the requirement to actually develop the experience to be the quality and accessibility that is needed. It's always important to find the right instant scaling solution for your application. There's reservation options, there's on-demand options, appointment-based solutions, and we'll delve a bit more into those solutions and the options that AWS has available.
Absolutely. So we've talked. Yeah, for sure. Happy to go into some depth here. So we've talked about the regional and local zone footprint or availability zone footprint. We've talked about the kind of specific infrastructure types that are needed to drive these sort of applications. But what's not commonly known is the flexibility and the control that exists to right size the infrastructure to develop and deploy these kind of experiences at scale. And at scale requires a cost-conscious approach as well, right? Total cost of ownership is absolutely a consideration for shipping pixels like this. And so we work on a bunch of different levers to create flexibility for customers and partners to right-size these workloads on AWS. It's worth talking about one maybe not as well-known solution from AWS, which is called on-demand capacity reservations. So this is something you can search for or look for on the AWS website. But to highlight some of the features of ODCR, as we call it, on-demand capacity reservations, is that it's a solution that helps customers create capacity reservations at any time, ultimately giving them the choice to select the infrastructure that they want to run their applications based on the target scale, without having to enter into a 1-year or 3-year term commitment to reserve those instances fully, right? We have a spectrum of options when it comes to reservation, because pure on-demand access to highly competitive and in-demand instances like the G5 class, for example, is not always a wise idea, right? It's good for bursting if you need to adjust capacity on a moment's notice. That's why the cloud exists. That's why you have the freedom to scale up and scale down. But with experiences like this, once you have some data around the usage and the model for users globally, it's better to plan for that. And ODCR, on-demand capacity reservations, give you a really good utility to be able to plan that capacity reservation while still having the flexibility to not commit to a longer 1-year or 3-year term. So it's definitely worth highlighting this. Ultimately, the way ODCR works is that the capacity becomes available and billing starts as soon as the capacity reservation is provisioned within your account. But when you no longer need the capacity assurance, you can cancel that capacity reservation and ultimately release the capacity back into the pool and stop incurring those charges. So it's kind of best of both worlds, right? You can reserve an instance pool to meet your projected demand. But if for some reason that demand curve changes, you're not stuck with that commitment. You can release that back to the pool and stop incurring those charges. So really a wonderful kind of balance between getting access to reserved instances while not having that upfront commit. Ultimately, you can also use billing discounts, which are offered by AWS, such as savings plans and regional reserved instances, to reduce the cost of a capacity reservation, right? So these benefit from some of the billing discounts that are offered, and that can be done in conjunction with your AWS account team. To speak a little bit about savings plans, ultimately savings plans do help reduce bills by up to 72% compared to on-demand listed prices. So once again, you have known usage models or known patterns. It's definitely wise to think about what a savings plan could do to ultimately bring down your overall infrastructure spend on AWS. This is done in exchange for a commitment to a consistent amount of usage, which is usually measured in $1 per hour for a 1-year or 3-year term, right? So when you commit to a consistent amount of usage based on your data and based on your patterns, you can introduce or enter into a savings plan to bring in those additional cost savings. These are just some of the impactful kind of cost advantage and TCO management utilities that we have, paired with performance that comes with our G4, G5 instance classes and the availability and scale we spoke about. becomes a very robust infrastructure to help scale these experiences, as you're seeing ZeroLight accomplish. Back to you, Chris.
Brilliant. Thanks, David. And yet, the other point to make is with Wi-Fi stability and internet bandwidth. With CloudXR, we always say it's much simpler than any other high-quality VR solution because there's a single point of failure, the internet connection. We found on home connections, interference is very rare and everyone has a great experience. When we've deployed to dealerships, stable and fast connections are common and often just require slight changes to router bandwidth management to avoid other users draining the bandwidth. But of course, events can be challenging, especially on hotel Wi-Fi, but there's always a fallback. A subset of the cloud systems that we're currently running on AWS can be ran locally. But this is not ideal for scale, but it's good for events. So we also have built in a connection monitor. As we mentioned, latency is key, but the headset does a lot to reproject data to reduce that latency as much as possible. The connection monitor lets the host monitor the stability of the connection. This data is synced from the headset session using the built-in CloudXR stats, and we share this to our MQTT service, which it then delivers the data to the host display. It's great to have that reassurance that the customer is getting the best stream possible and performance isn't dropping. And finally, we have session login and data collection. With all ZeroLight products, data is key to understanding the usage levels and the return on investment. This data can also help issue tracking and support. This is essential when we are looking at a worldwide deployment, as the data can provide answers without the need of syncing across time zones. So now let's take a look at a real-world use case of CloudXR Automotive Retail. So what is this project about? Well, it's best said by the project visionary from Aston Martin, Carly Hardacre. She says, designed exclusively for Aston Martin customers worldwide, the Valhalla VR experience offers an immersive and interactive showcase of Valhalla's sensational design. By leveraging virtual reality technology, we provided customers with an exclusive experience offering a spatial exploration of both the exterior and interior design elements with a tailored virtual environment. Through the guided CloudXR integration, users were treated to intricately detailed visuals seamlessly delivered without the constraints of cables or controllers, ensuring a truly immersive experience. So if we run over the experience, the customer places on the headset, starting in a comfortable mixed reality scene. They adjust the headset to get the clearest possible visuals. Then on the host device, they load up a web page. They select a unique code pushed from the headset to sync the two devices together. The magic of the solution is that it can be one host to many customers, and it can even be controlled from opposite ends of the world. In a few seconds, the headset connects to an instance in the closest data center and starts streaming the VR content. The host can guide the user around the car by teleporting them, triggering animations, switching configurations, and transforming the environment. The customer still has full freedom to walk around and inspect the details of the car, but they don't have to worry about the navigation from one side of the car to the other. This is where the sales associate can trigger an action on the tablet to teleport and guide the customer around. This is great for a sales experience, as you can ensure the customer sees all key features. So this is ZeroLight's CloudXR offering. As it stands today, you can have the option of ZeroLight to build the full experience starting from $100K. From digital twin to VR experience, or we can stream your VR applications, your VR experience with our enterprise standard cloud streaming solution, which is called OmniStream, which starts from $3 an hour. And that's not quite the end yet. Let's have a little time to talk about where this technology is going. So as mentioned earlier by David, AI is a key accelerator of extended reality and spatial computing, as highlighted by David in the beginning. We break it down into 3 areas where we focus on creating AI solutions. The first is data processing, the automated QA of digital twins. We work with very complex digital twins with millions of unique configurations. It's important that we can automate and detect any issues early in the pipeline. The second area is content creation. This is where we see most from Gen AI, from background and light into 3D assets. This technology helps create fuller, more immersive worlds and enhances the immersive experience. And then finally, we've talked a lot about how the sales associate guides the customer around the VR experience. Obviously, the future is AI guiding you through this personalized sales experience. So perhaps even more exciting is the future of these XR experiences at home. With Meta Quest 3 and Apple Vision Pro expanding the home VR adoption, there is an expectation for brands to have spatial experiences. A VR sales session length is relatively short. You don't want your potential customer of a high-value item having to wait for high-quality assets to be downloaded, not to mention security concerns with these digital twin assets. With the CloudXR solution, a customer can jump from configuring the car on a browser or a tablet to an immersive experience in their own headset. This additional spatial understanding of the high-value product they are about to buy will become an essential part of the online sales journey. And so we've sadly come to the end of this webinar, but hopefully you have seen how the pieces of the puzzle are all in place. The solutions are ready to deploy, and I look forward to hearing from you soon and seeing the exciting future where large-scale, high-quality VR sales tools are the standard step along the automotive sales journey. And finally, a big thank you for listening, and a massive thank you for David joining us today. The information you shared was extremely interesting and extremely useful. And please, if you have any more questions, put them in the questions box or connect to us online. Thank you.
Thank you kindly, Chris. It was a pleasure to be here, and all the best. You've done excellent things with our infrastructure.
Thank you.